longer to finish the attempt and finish the grade. I am not going to do any more whole shabam problems like I did yesterday with number 7. Whoop, there it is. However, I do and I would love to be helpful if I could in explaining the directions and explaining the givens and explaining the answer key. Where do you want me to jump, Kyle?
11C.
Nice. Let's go to number 11. Some of you are like, I didn't get there. So go to number 11 and start reading the given information, because if we are in a part B or are in a part C or are in a part D, you had to have thought through at least what was given. Concert tickets. Somebody was roasting the question yesterday being like, BTS sold out in how many seconds, minutes? This was 9 hours. Pause. This is from 2008. A bit before the online ticket sales were quite as extreme as they are now.
Yeah.
Or whatever else. There was a big old Adele concert a few years ago. When was that? And that one sold like, that one refresh. Anyway, whatever concert you want to say that sold out.
He was like, I was there. That's what you know.
Because it was during the school day, and a friend and I were both trying to get it. So then coming back. The network at school is never a good network to use. But long story short, okay, before the whole like crazy, it sells out in 2 minutes, and all these people buy tickets that are just going to sell them anyway, and it's basically a huge business thing. Okay, we need to reorient. You guys are reading the given information, and as you're reading the given information, as I reorient the screen, make sure I hit the record button when I come back, if I have not yet already. What's the given info? Situation, concert tickets, got that. What's going on? Okay, start off easy. What do you see? A graph, a table, a function?
A table.
Okay, only a table? Keep looking at anything else?
You get modeled by twice the differentiable function.
Okay, but no graph and no function, right? In more recent AP questions, they don't just give you a table for this type of problem. They'll probably give you a table and a graph, or a table and a function, or a function and a graph, kind of like the runner one. Which one's the runner one? The runner one, number 8 or number 9? They love giving you multiple representations. This one just gave you a table. Okay. What's in the table? Is it an amount or is it a rate? Amount, because it's people. What would a rate look like? People per hour. Exactly. So I have an amount of people, and I have, wait, do I have a full comprehensive picture or little baby snapshots? Little baby snapshots. I know what's going on at 0 and at 1. Do I know what's going on between 0 and 1? No. Do I know there's an average increase? Yes. Do I know it's continuously increasing? No. It could have been. Right? There could be some variation. I don't know. I just know what's going on at 0, at 1, at 3, at 4, at 7, at 8, at 9. Okay, letter A, my advice would be average rate. F of B minus F of A all over B minus A, but don't you dare write that, because it would be L of B minus L of A all over B minus A. Wait, that makes no sense. It says at 5.5. Why are we doing between an A and a B, and what are those A and B's? What is that A? What is that B? They didn't give me 5.5, and they didn't give me an equation to take a derivative of. I can't figure out the rate at 5.5, but I can go between 4 and 7 and say on average and call it approximate. Okay, but letter B, when it says trapezoidal sum, wait a minute, if we're doing area, guys, in this idea of amounts and rates, what does area approximate? The integral is area, right? A derivative would be a slope, like a y2 minus y1 over x2 minus x1. To do a derivative, to get a rate from amount, I need to take a derivative or a slope. If I'm trying to do a trapezoidal sum, I must be doing an integral. Why was I doing an integral in part B as I'm getting closer and closer to Kyle's part C question? What on earth? I know trapezoidal sum is area, so I'm doing an integral, but why an integral?
You're getting an amount.
Average what? Average rate or average value?
Average value.
Because you have amount. You want an average of what you already have. True?
Yep.
So then wouldn't you be using 1 over b minus a, the integral from a to b of, wait a minute, it says 4.
A minute?
Think about the 4. Is that really just at 4? Or is it over 0 to 4?
0 to 4.
Got it.
First 4.
So we need the 1 over b minus a times the definite integral from a to b of my quantity I want the average of, and the quantity I want the average of is number of people. Plug it in, plug it in. I can't, there's no function exactly, which is why I'm going to do 1/4 from my 1 over b minus a and use my trapezoidal sum to approximate my integral. Sorry, part C. I was just helping out those few of you that might have gotten stuck somewhere earlier. Part C says, what is the fewest? Whenever you see the fewest, or the at least, or is there guaranteed, or how many guaranteed, or how many must exist, etc., 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 you should be thinking of an existence theorem. An existence theorem. I've mentioned it a couple times this year, but you guys might not have picked up on it. An existence theorem. An existence theorem. Which theorems guarantee that there must exist a special x equals c such MVT. What else? IVT. What else?
EVT.
Technically EVT. So which one is this referring to? Existence theorems. Think about x equals c. Well, who's guaranteed the c? IVT, MVT, EVT, EVT, extreme value theorems. There must be an absolute max or min. This isn't talking about highest or lowest. Well, I mean, it does say fewest number of times, but it's not asking for absolute extrema. IVT says, well, to go from here to here, you must have hit everything in between. Do I have L primes?
No.
No, I have L's. So this isn't IVT. I can't look at the L primes and say it had to go from here to here. So I have L's, I'm looking at derivatives. Which of those three talk about derivatives having to equal something? MVT. What does MVT say?
And a differentiable on the open interval.
Here's the nice thing, is that with any sort of, I don't know how I want to put this. With any sort of motion or quantity movement, you're going to have continuity and differentiability. Now, I mean, we could look up here and see, but if we're talking about real people buying real tickets, it's kind of like real motion. Oh, and the nice thing is, wait, it says twice differentiable, so I'm good. This is saying L exists and L prime exists and L double prime exists, which means, okay, perfect. So my L is both continuous and differentiable as stated up above, so I'm totally good saying that. They didn't even make me guess it. MVT applies. On 0 to 9. Which, not requires. What am I trying to do? What am I trying to say? Guarantee, which guarantees at least. Do you guys realize I'm answering the question without having figured it out at all? I've done the ifs, continuous and differentiable. I've stated the theorem I know applies, or the theorem that I know I need, MVT, and I'm about to state the answer. I just need to go ahead and figure out how many times, right? So far, I've needed to know nothing except for my forever card and which one to apply. So L is both continuous and differentiable on time interval. MVT applies on 0 to 9, which guarantees at least, okay, now it's time for me to figure out, right? Zeros of L prime because, okay, I have a couple things to fill in, right? I have a couple things to fill in. I have a couple things to go back and look at. However, do you understand how I have pretty much set up the form of my answer without having totally figured it out yet? Do you see it? I'm going to try to make this just a little bit thinner so I can fit a little bit more on this section. Okay, so what does MVT actually tell me?
For the
continuous and differentiable function on a closed, well, on an open and a closed, closed and then open. There exists at least one x equals c, and I'm going to assume that there's more than one because they said the fewest number of times, such that f of b minus f of a is equal, all over b minus a is equal to f prime of c. In this context, we can think of MVT. What does it guarantee? It guarantees L primes so it wouldn't be F anymore, right? It would be L. Okay, that's what MVT is applied to this problem. There are L prime values at different C's in between different A to B's such that the average equals the instantaneous. Now, what do you guys see in this table? We have to go back to our table. Could I figure out the average rate from here to here, from 0 to 9? Yeah. I could do L of 9 minus L of 0 all over 9 minus 0. It'd be negative 120 all over 9, which is, I don't know, something. And I could say the derivative has to be negative 120 over 9. But does that help me for this question? That L prime must be 0. Is negative 120 over 9 0? No. Okay, well, I could do it from here to here, but is this going to be 0? Is that going to be 0? Is this going to be 0? Is that going to be 0? How do you know, Adam? How do you know real quick these aren't 0? What would it take for the average rate to be 0?
The LO
Rolle's theorem. We have to have f of a equal to f of b, or L of a equal to L of b. Well, here's the problem, and here's why I don't have you make a full brand new card for Rolle's theorem, and here's why I just say use the MVT no matter what, even if it says 0. Do you see any of these y values that match any other ones? So Rolle's theorem is not going to help me. MVT will, though. Because even though I can't stare at this and say, yeah, of course there's a 0, or yeah, of course there's a 0, I can say, wait a minute, MVT guarantees average rates, right? So average rates, question, is this an average increase or decrease from 0 to 1? It's an average increase, which means the derivative had to be positive, that average increase, at least once. How about this? There's an average increase, but then all of a sudden there's an average decrease. Average increase, average increase, average decrease. What's going to happen somewhere between 1 and 4? A sign change. And where do or how do all sign changes occur by IVT? At zeros. I have a guaranteed 0 of L prime in between 1 to 4 because of MVT and IVT. MVT says there was an average increase and an average decrease. IVT says then the guaranteed derivative must change from a positive to a negative at a 0 at least once in there. Are there any other places where this 0 is going to, or another 0 is going to be guaranteed by similar logic? The AP loves it when you say by similar logic, and you just cut your work in like half or thirds of it. Similar logic. Do you see any other ones? Where? Because it goes down and then up, right? Wouldn't it be 3 to 7? See it? I need to get the average decrease and then the average increase. I need to get that whole situation, whole scenario. Any other ones? Up, down, yeah, 4 to 8. And then it's just down, down, right? So then technically, I need to come on down here and try to just explain that. But I have, help me out, you guys have it, right? 1 to 4, 3 to 7, 4 to 8. So let's fill this in. More and more the AP is loving. I just oriented you. Okay, it's all right. I think it's fine. I'll use your guys' phrase. Not using an Adam's. At least 3 zeros. There's going to be at least 3 zeros of L prime of t because it's going to be thick. make it short and sweet. I usually take up like a half page with this, and I only have it.
I have a question.
Yeah.
Do you have to like use like,
I have to use IVT too.
if you use like this, like specific of like language, like, I don't know.
Yes.
Okay.
Doesn't mean this is the only way of writing it,
Yeah.
but you do have to be specific. Because you have to have your ifs met in order to apply your theorem, and then you have to state what your theorem and how your theorem brings you to your conclusion. Does that make sense? On, what'd you guys have? It was 1 to 4? 3 to 7? And then 4 to 8? I'm going to come up here and I'm going to say IVT. Sorry, I'm trying to get so much shorter than I normally do. I can say IVT and MVT applies, now that I know that I need IVT also for the sign change. Which guarantee, I mean, they're not going to take off for grammar, but let's at least try to be somewhat proper. We have 2 different nouns and a plural verb. Guarantee at least 3 zeros L prime on those 3 intervals. On 1 6, on 1 to 4. I'm just going to cut in the D. The average increase on 1 to 3 and average decrease on 3 to 4. Indicates L prime of T must change from, average increase came first, right?
Yeah.
Positive to negative at least once within that interval. And by similar logic, yeah, you just cut out having to actually walk through the other 2. By similar logic, 2 other zeros
Oh, you don't even need to explain.
are, nope, guaranteed. You just have to demonstrate sufficient
Like at least
mastery of the topic. Yeah. Are guaranteed on the other
Oh my goodness.
2 intervals.
I can take a picture of that.
You guys seen how bad my orientation got in the last 5 minutes?
That's supposed to be for C, right?
Yeah, that's all for C. Now we can go check out Capital's Maximus. Remember, he's a different teacher. He might have done it a different way.
Yeah.
And even the AP guys, like they have different ways that proving this are totally legal. According to him, this was 11. Was it 11?
Yeah.
Now guys, check it. Did he show a lot of work on 11C too? He went ahead and was very specific. He plugged in and showed the positive average rate, showed the negative average rate. I just stated it in words. And then he said, okay, so by MVT, L prime must be positive and then must be negative. I just said must change sign because I already stated MVT. So you could go more in depth. Then he went ahead and said IBT applied, but remember I went ahead and threw in IBT applying because of the twice differentiable. I didn't state that, but I did say continuous and differentiable. This is just saying like, hey, I read the problem and I understand what you told me and I can now use these. So this is actually probably a little bit better way of saying why MBT and IBT apply. But check it, he says that, and then, ready? Similar arguments can be made. I just said by similar logic or by similar, what is it? There we go, at least 3 values.
Is there like a thing online where it like shows you all the different variants of answers that are all correct?
You see how I actually gave you, or he gave you, but I copied it off, that it was the 2008?
Yeah.
Depending on the year, especially the last 10 years or so, I'm not sure if it will go all the way back to 2008, but if you just search, ready? You want to go to College Board, AP Calculus, free response.
Did they have like a creative center?
Yeah. You go to past exam questions, not multiple choice. They don't ever give us those. But they do give us all the free response questions from the last however many years. You can go looking for 2019, 2020, you can find it. But Adam, if you go back to 2008, was this Form B? Did it have a B anywhere?
Form 2.
But check it. You can go ahead and, oh, that's question 2. It was 2 out of 6. There are different questions that show up in number 1, number 2, number 3, number 4. If we go to scoring guidelines, Adam, let me just show the rest of you guys also, and student performance Q&A. This is like from the actual graders, their response to all the ones they graded, and the other scoring statistics as well. But then you can also go to question number 2. Kyle, you mentioned it was 2, right? And see the details. So you have your answer key, which is basically what this one shows you, just the scoring guidelines show you everything. Well, it shows you nothing right now, so that's cool. But it shows you the scoring guidelines of how they would have answered it. Now check it. See how there's an or? Couple different ways of doing it, but do you see how one is more like mine with lots of wordiness, and then the other one is kind of more like his with lots of plugging in? But still, all of his math was not necessary. It wasn't in either of the answer key sample solutions. You could have gotten up to 3 points in this. One would have been thinking about how L prime is changing signs, aka how the average rates are changing signs. The analysis has to do with whether or not you are correctly using MBT and IBT for the most part, and then you have your conclusion of at least 3 values. But then after this, they have usually a high, a mid, and a low scoring for how people answered it. So you can go see how a student did, and then you can read at the or how they wrote it. You can read at the very end their analysis of why this one got a 9, why this one didn't, why this one even didn't. Is that cool? And then the other one is their overall, not with actual sample questions, but how or why they made the question, the topics that were included in it, and what they thought the students needed to show and what common errors are. So there's a lot of cool analysis stuff for you guys to go check out on any question that ever seems like, I think I don't have a good handle on this. I definitely want to learn more. So then coming back, boop, boop. Kyle, that was a great question. In that they love to use a table or have a table, give you a table, make you somehow apply MBT or maybe IBT too. And they've gotten more and more away from just simple rules problems where you have to do a deeper analysis. Okay. Anything else for those of you guys that worked through the answer key? Sorry, we both took that C, but I was trying to show you big ideas. And also show you guys online what's available to you on any question that ever is confusing.
If we don't write all of that,
Well, hold on. I just closed all of those answer keys. That was a great question. It's not about so much writing all of that, it's about getting all of that. Does that make sense? I think this is the fastest way for me to get it. And in the sense that you have to have a reason as to why you're allowed to use MBT or IBT. If you don't state the reason, or if you don't pick out the twice differentiable and be like, oh, I'm allowed to, then you're not showing full mastery, you're just guessing and hoping. So you have to show why you're allowed to use a certain theorem. You have to actually use that theorem. So somehow state your answer in a way. I mean, you had to get to 3. But state your answer in a way that you are demonstrating full mastery of full comprehension of why the answer is what it is. So I'm just going quick back to we didn't look at it for very long, and that was my bad. Their version of the scoring guidelines. Oh, that was the one that didn't open. Let's go question 2. Oh, it did open this time. Okay, so question 2, check out what they did. They stated it's differentiable, which in their minds means it's continuous, but careful, we actually need to probably state that since they took off the random point this last year that all the teachers got mad at for not saying differentiable and continuous. Anyway, different problem, there was a reason for it, but MBT implies both of these. Oh, that one doesn't even use MBT. That goes about with relative extrema. I think MBT makes the most sense, and that's how I'm teaching it, so I'm hoping that's where your brain will go. But they just said, check it. They're just saying, like, hey, it's going to go up, and they don't even use, like, the average rate wording. They're just saying, I know MBT tells me this guy has to be positive. They didn't even say because of the average. They're just saying, yeah, I know MBT. Duh. I know MBT. Like, it's also going to go down in another interval. So if it goes up and if it goes down, then IBT has to say there's a 0. Like, there are different ways of literally putting the structure together. It's just the idea, the concept has to be there. I think this is way more complicated as far as an analysis. I think the mean value is the most straightforward.
You can just say get the maximum. I feel like to me that is like
this one's just, it's using the idea of MBT and average rate and continuous and differentiable. If it's going up and then going down, it has to have had a relative max. MBT guarantees a 0. This one's saying, I don't care if it's 0 or if it's pointed, it's there. This is a little bit different way of putting it. But this is way softer of an argument, and softer arguments sometimes don't fully prove, which is why I'm trying to trash that whole thing. But they did write it out because they were like, well, a student could make an argument, and mathematically to them it was sound. I just think this is solid, this is a little shaky. Does that make sense? You can read it and see it. But Kathleen, please, 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 you can go check out this student sample, and you can read through their analysis of this question, because I admit this is one of the trickiest ones as far as forming and as far as writing out. I think out of all the AP exam questions I've seen, this type of argument. So the best thing that's going to help is you getting exposure and then coming and figuring out which way works. Am I jumping somewhere else in the FAQs? 11, 12, 9, 8, 6, 5, 4, 3, 2, 1. I mean, we already did 3 and 5 and 1 and 2.
these are all like AP.
Yeah, I think the multiple choice are a little shaky. They probably came from different samples. College board assessments, they give like practice 1 or 2 syllabi for teachers to look at. They do release a few different sets of multiple choice. Multiple choice, though, they are way, way more secure on. They do not give those out because multiple choice do get barely reworked and reused. Not year after year, but it's like a huge multiple choice bank that they kind of just pull from. So they don't let that one out. But the free response, they let you guys see exactly what questions they've asked. Okay, then we're going to go ahead and at least introduce Chapter 5. If you guys are totally ready, this is ready to be turned in, just pass it on up. I'm going to do a quick sweep through and grab any of the ones that have been passed to the front. Trying to see if there's anything else I like on this page. Did I write it any differently? No. No, I like this year's Forever card way better. Woo! Slow fields, this is a party. Okay, any more packets that I missed that you wanted to put in right now? Okay guys, check it. Check it. Where am I putting this? Right here on the very top of your tray, which is the far left-hand side, yeah? So by the end of today, far left-hand side. To be completely honest, I'll be honest, I'm probably not going to pick it up until in class tomorrow. In your class tomorrow. So, can you have it in by the end of the day? Yes. If you forget, slide it in. I'm giving you a full week. I'm probably not going to pick it up because I've been working on stuff like catching up, and that is not my top priority today. But tomorrow in class, I'm picking it up and we're going. Okay. Section 5.1. I do have a couple packets. One to be used in class starting tomorrow, and one to be used for homework, like a little bit of an extension, but not as AP-ish, not as free response-ish as this. As the, what we just do, integration, does that change? These are more multiple choice when they show up, if they show up, or like a part A of an FRQ. This section, this chapter, introduces a whole other type of free response that will show up in some way, shape, or form on me, for sure. So what we're, this section is just introducing like multiple choice topics and an application of differential equations. Oh, chapter 5? Differential equations. Which, in college, there is an entire class that all engineers, all math applied up here. Probably computer programmers. Yeah, probably computer programmers. Who else? Anybody in tech, probably, needs to take, called DiffyQ, differential equation, ordered differential equation. Chapter 4's title was more integration.
More integration.
We had intro to derivatives, and then more derivatives. We had intro to integration, and then more integration. Some might call it basics of integration, and then further integration. Different ways of saying it. Today.
What are you not ready for?
The question is your work ethic getting to where you will be ready for this?
See, I can say yes to that.
Adam is the star of our
Sorry, I heard my name. Andre, was that you?
Yeah.
Yeah.
I couldn't find any sandwiches this morning, but I have it here.
Oh, you have it. I want you guys to write next to slope fields the following: baby tangents.
Go.
Baby tangents.
Not tangents. Please go on tangents.
Baby tangents.
Are you?
Well, there is something called Euler's method. My CalcBC kids in the back might appreciate this.
Oilers.
There is something called Euler's method. His name is spelled E-U-L-E-R-S. He's a famous philosopher, mathematician. If you've ever read it or seen it, you probably thought it was Euler's, but it's not. It's Euler's. Like Ferris Bueller's Day Off. You might have thought it was Euler, but it's...
Bueller.
I know, most people haven't watched it.
It's on there.
Euler. Oh, it is?
Yeah, it's
It's a classic. How to ditch class. I mean, don't do that. I don't...
Is this the one where like the graphs are all like the crazy like liney things?
Yes.
And Ice Cube.
So, Euler's method, E-U-L-E-R-S, is even a little bit better as far as, Kyle, what you were saying about going off on baby tangents, because Euler's method says, let's do a tangent line, oh, let's do another tangent line, oh, and it's trying to, like, go after a parabola, but not in one line, but lots of little lines connected. That's called Euler's method. We're not doing that. We could. It's tangent lines. We could. It's dangerous. I need to just get my creamer and then walk away from this table and say, I thought we can't go. But this is not that. However, it's another application of baby tangents. Oh. At least it was mine. Okay.
Sure.
I hope my hair. I'm not sure how another hair. I just washed it this week.
Oh. One time I got so good. At church, I drank half and half. So thirsty.
Okay, baby tangents. You guys see a visual perspective of solutions to differential equations. I need you guys to pause for just a second. I have mentioned differential equations a couple times, and oh my goodness, it's the title of this entire chapter, which is introducing to us a whole other huge topic for free response questions. Differentials. Where have you heard that before this year?
Differential quotient.
Difference quotient.
DX.
Difference question. dx was what? Differential x. dy was differential y. And when you watch the calculus controversy video at the beginning of, I forget when I showed it to you, sometime. The year? Was it the year? Oh yeah, because OChem tutor guy, he was the beginning of second semester. When I showed you guys the calculus controversy focus, it also talked about how Leibniz was the one that brought in the cool notation that we still use today, using differentia, which led to differential, which led to dy dx, instead of using the idea of infinitesimals, which is like Newton. Newton was arguably probably smarter, but Leibniz, was more practical in that he brought in this cool notation that we can use to kind of shortcut some of the methods today. Differentia, differential, dy dx. So, can you guys go ahead and write underneath this to prove a point, write dy dx equals. Whiteboard.
Oh, sure.
Oh my goodness, wait a minute. Wasn't there in the practice test for the test you just took, wasn't there like a whole category of questions that you guys didn't like because they didn't have integrals actually written? And instead there were words with dy dx's? Do you not remember the very back page of the practice test, the bonus practice test? Where there were the weird dy dx's? Man, that coffee is hot and this cup is not very insulated. And I was like, don't worry. I even wrote it on the board if anybody was in here, and I said, what is today? Everything with integrals. What is not today? This stuff. But it is this chapter. What if you are given a dy dx? And let's say you're also given some sort of clue. Question is, what can you do? What if you're given a dy dx and you're given some sort of clue? Now hold on, this is in like the chapter 4a that you just did corrections on. Test, you were given a differential equation. I just might not have called it that. You were given a derivative, you were given a clue, and you were expected to go, what's one thing that you can do that you've already done? Find y equals f of x. Including plus c. Remember this one on the test correction if you guys needed to do it? You were given a derivative and you had to go back to an original, and the way to go back to the original was to take the integral of both sides. Wait a minute, we can't take an integral of a dy over a dx. There's a y and an x all on the same side. Which is why we would move the dx to the other side. And if there were x's and y's, we would move those as well. To get the y's on one side, the x's on the other side. That is section 5.2. That's what's coming in our third application of, well, actually, it's still in the first application of these get harder. These get harder. That's going to be section 5.2. However, we're not in section 5.2. We're in section 5.1. So this says, slope fields, these little baby tangent ideas give us some sort of visual for the solutions to a differential equation. And if they get harder, and even further, if they get impossible for us to solve by hand, is there another way to still use this, to still have an idea of what the original looks like? And the answer is yes. We can use the equation to get a slope field. We can say, hey, you're helpful or you're useful for something, not just for separating and integrating and going back when possible, but also for graphing a slope field. Now, let me try to, we're not going to have time to really go into that. Let me try to get you a picture of a slope field. You ready? Those are us making slope fields. Here's one.
What in the world am I looking at?
Little baby tangents! Wait, if these are little baby tangents, is there something flowing through? You guys should look up wind maps. You should look up wind maps online.
Is it
F? Wind maps.
That one F?
This sign is the y, which means dy dx is the cosine. They could ask you for the y's, or they could ask you for the dy's.
I don't like this, Miss D.
We're going to make little baby tangents, and we're going to try to figure out clues of making our own and of figuring out which one goes with which. That's tomorrow. Bye, guys.
Wow, you're going.
But now you see why there's a packet, because this could be kind of hard to like write down in our notes ourselves. Bye, cool kids. See you later. Let me get back to the beginning and pause.